Hello everyone and welcome to this video on proof by induction. So in this video we want to prove that 7 to the power of n minus 4 to the power of n is divisible by 3 for all values of n greater than or equal to 1. Okay, so to do this using induction, we need a base case, we need an inductive hypothesis step, and then we need a deductive proof step. Okay, so in the base case, I want to check to see if the statement is true for the smallest number that we can consider. So I'm going to put that here. So here we're going to check that the statement is true for the smallest number we can consider. Okay, so what's the smallest number? Well, the smallest number is when n is equal to 1. And that comes from our statement right here, right? N is greater than or equal to 1. So the smallest number that n can be is 1. And now how do we check that? I'm going to change the color here to green. Well, now we substitute 1 wherever we see n in our original statement. So we get 7 to the power of 1 minus 4 to the power of 1. And this is equal to 3. And now we check, is 3 divisible by 3? The answer is yes. So this statement is true. And that's good. If it was false, then we have already disproven this. All right. Next, we're going to go to our inductive step. So what do we want to do here? So in our inductive hypothesis step, we want to assume the statement is true. Okay, so what do I mean by that, right? Well, we're just going to assume that 7 to the power of n minus 4 to the power of n is equal to some number that's divisible by 3. So it's equal to 3 times, we're going to put t here, and t is just going to represent some arbitrary integer value. Okay? So we assume that this is true, and we do this so that we can use this later in our deductive proof step. Okay? So next, let's go to the deductive proof step. So in this step, we want to show that for n plus 1, this statement is still true. Okay? So here we're going to check, is the statement true for n plus 1? And that's a question. That's what we're trying to figure out. And what do we mean by that, right? So by that, we're really asking the question, is 7 to the power of n plus 1 minus 4 to the power of n plus 1 equal to 3 times some integer s? So is it still also divisible by 3? And we're going to be using our inductive hypothesis in this deductive proof step. Okay, so let's go ahead and create another page. And I'm going to state that again, what we're going to be doing here. So basically, we're going to try to prove that 7 to the power of n plus 1 minus 4 to the power of n plus 1 is equal to 3 times s. And really, what we're going to be doing is a bunch of intermediate steps in between, and we're going to see, does this equal 3 times some integer value that I'm going to call s. So this is just a question mark, right? We don't know. It's really a question mark. Okay. Let me just erase this, and then we're going to get started. Again, we're going to be using the inductive hypothesis, hopefully, in this statement, right? So we got to try to get it to that form where we can actually use that inductive hypothesis, and we're going to use some properties of exponents and other rules of algebra to obtain that expression, 7 to the power of n minus 4 to the power of n, so that we can use that inductive hypothesis. All right, so let's see here what we can do. 7 to the power of n plus 1 minus 4 to the power of n plus 1 is equal to 7 times 7 to the power of n minus 4 times 4 to the power of n. Oh, let me write that further down, actually. Okay, so it's equal to 7 times 7 to the power of n minus 4 times 4 to the power of n. Okay, and now I can rewrite this further. I can change that 7 to be 3 plus 4, and I get 7 to the power of n here. So 3 plus 4 times 7 to the power of n minus 4 times 4 to the power of n. And I can multiply that out, so we get 3 times 7 to the power of n plus 4 times 7 to the power of n minus 4 times 4 to the power of n. And now we can take out those 4's. So I'm going to rewrite this. We get 3 times 7 to the power of n plus 4 times 7 to the power of n minus 4 to the power of n. Okay? And guess what? This is the expression that we had in our inductive hypothesis step, and we said that that's equal to 3 times some integer value t. Okay, so we can rewrite this again. This is equal to 3 times 7 to the power of n plus 4 times 3 to the power, 3 times t, right? Because we said 7 to the power of n minus 4 to the power of n is equal to 3 times some integer that we call t. All right, now we can rearrange this a little bit. So we get 3 times 7 to the power of n plus 3 times 4 times t. Okay, and now we can pull out that 3. So we get 3 times 7 to the power of n plus 4 times t. And this is equal to 3 times s, where s is equal to 7 to the power of n plus 4 times t. And t is an integer value, and therefore that full expression is an integer value. So here I'm going to put 3 dots, which is a symbol for therefore. And we're going to say therefore, because 7 to the power of n plus 4 times t is, let me rewrite that a little bit better, okay, is an integer, comma, we proved that 7 to the power of n plus 1 minus 4 to the power of n plus 1 is equal to 3 times s, and therefore by principle of mathematics, or principle of, I should say, mathematical induction, the original statement is true. Okay, and that's it. So thank you all for watching. I hope that this was educational to you all, and I hope I broke it down and explained it very well, and hopefully didn't make any mistakes. Please let me know if I did. Anyways, I will see you all in the next video. Thank you for watching. Have a good day. Bye-bye.